A spring is stretched by hanging a variable mass on it of m. The mass m is always at rest. The spring obeys Hooke's law. What is the relationship between elastic potential energy E in the spring and the mass m? Okay, so let's think about equations for elastic potential energy. We have E is equal to a half Fx, and then we can use the equation F is equal to Kx to rewrite this as a half Kx squared. That's just replacing the F with Kx. But a problem with both of these equations is that neither of them involve the mass m. We have elastic potential energy, but we don't have the mass m. We want to get some kind of relationship between these two things, so we're going to have to get mass in here somehow through some other equation. We can do that by considering the forces on the mass. There is a tension force upwards of Kx, and there is a weight force downwards of mg. Those two things will be equal. So the spring force, which is Kx, is equal to mg. We know that's the case because we're told the mass is always at rest. That means it's in equilibrium. So what we can then do is we can use our equation that we have over here, E is equal to a half Fx, and we can replace the F that we have here with mg. That gets F in terms of m, which is what we want. Then we get E is equal to a half, F becomes mg, and then the x, we're keeping it as it is for now. So a lot of students got this question wrong. Maybe they got to this stage and then they said that E is proportional to m. But a problem with that is x is also a variable. X also changes. When we're trying to find a proportionality between two quantities, we want those two quantities to be the only variables in the equation and everything else to be a constant. Half and g are constants, x is a variable, so that's a problem. We need to change that into either a constant or we need to change it into a function of either E or m, the things that we want to have in our relationship. So then we can do that by using this equation here, Kx is equal to mg. We can rearrange that for x. X is then equal to mg over k, and then we can sub that into the equation that we have here. So then that becomes a half mg times x, which is mg over k, and that simplifies to make m squared g squared over 2k. G squared, 2, and k, they're all constants. M squared is the only variable on the right hand side, and that means that E is proportional to m squared. That is option D.